some things that you need to definitely pay attention to as far as service on this AF21. A lot of shops are dealing with this transmission right now, and so we're seeing a lot of them come through the doors, and there's definitely some things you need to pay attention to. It will sound like I'm harping at you on some of this stuff, but it's extremely important that you follow some rules and guidelines as we go through this, because again, it can really shortcut your diagnostic time, as well as obviously make sure that you don't have a comeback on your hands. So with that said, we want to talk a little bit about, before we get started into our webinar today. Next webinar is going to pop up for you guys. It's going to be on September 4th. We're going to talk about the 722.9 Mercedes on September 4th, so hopefully we'll see all you then. We're going to follow that up with our Powertrain Expo in Washington, D.C., so I hope we're going to see everybody there. That's going to be the 19th, 20th, 21st, and of course the 22nd of September. When we go into the October scheduling, the first webinar you guys are going to see popping up in October is going to be October 2nd. We're going to be doing a reprogramming webinar. So we're going to deal with reprogramming and reprogramming issues. So we'll get you through how to do the programming process, as well as some of the issues you may run into when you're doing programming. Today's presentation, as it has been in the past, it is sponsored by Seal Aftermarket Products. You can reach those folks at www.sealaftermarketproducts.com. And of course, there's a toll-free number in your handout for that also. How started into the product itself. Connections, major issue obviously with connections for webinars. So make certain that your connections you have are hardwired. In fact, I'm running into a little difficulty right now with mine here. So we'll see if we can get it to update here. Oh, there we go. Okay, so connections, again, make sure you're hardwired, not through a wireless router. If you're having a connection problem, you can contact Lance or Sean at ATRA, and they may be able to help you out if you're having some issues there. The handout was emailed to everybody. In fact, there was an updated handout that we developed because we had a little problem with the nomenclature on one of the slides. The terminologies were not correct, so we have fixed that. In fact, we fixed it before we even did a webinar, but we wanted to make sure everybody got their latest and greatest webinar. Sean mailed those out yesterday to everybody. If you have a question as we're going through our process itself today, feel free to ask it. A couple different ways you can do that. You can raise your hand if you're a brave soul, and we'll call on you, and you can, through your microphone, ask the question. Most guys, in fact, it's the most efficient system we've got, will simply click on the questions button and type the question in, hit the submit key, and that will automatically pop up on my screen, and I will then read the question for everybody, and we'll respond, obviously, to the question. So that's by far the simplest way to do it. So if you got a question, simply type it in, hit the submit key, and it's going to pop right up on my screen. When we're all said and done with our process today, there's going to be an automated survey that's going to follow this particular webinar. We appreciate you filling the automated survey out. That kind of gives us a feel for how the webinar went, whether you're having any kind of communication issues. Obviously, with the handout itself, we had any issues with that. Basically gives us a little bit of feedback about how the webinar actually went. Today's webinar we shot for the same time frame that we have with the other ones. We like to have a webinar somewhere between 30 minutes and 45 minutes. This is right at half an hour, maybe just a hair over half an hour, depending on how many questions we get. So again, with that said, we'll move on to the next thing. I'd like to give a special thanks to Jeff at Valve Body Express. He really stepped up to the plate and helped us with some specialty information on these transmissions. Valve bodies are a major problem with this unit, and so again, he was very helpful, and I certainly appreciate his help. So let's take a look at the AF21 or AF21 or TF81SC, depending on which market you're in, what you're going to call it. This is a 6-speed Asian Warner or Eisenwarner, again, depending on what your nomenclature is, how you'd like to determine what you call Asian Warner or Eisenwarner. The transmission itself is very similar to other 6-speed front-wheel drive transmissions you've dealt with in the past. One kind of an exception here is, as you've noticed, the picture shows you the controller mounted to the top of the transmission itself. That controller also contains the Prendl switch, so you're going to actually adjust the position of the controller in its interface with the transmission to actually adjust your Prendl switch adjustment. So realistically, the TCM is what you're actually looking at in the picture. The PCM is separate of the TCM, so any communication for engine load and so forth occurs via the data bus over to the TCM via the TCM itself. When you look at the tags on these transmissions, they may not say AF or AF21. They may say TF81SC. It really doesn't make any difference what it says. It's the same exact transmission. We're giving you a listing of the American vehicles that have it. Many Fords, obviously Mazdas, Volvos, and so forth, and of course the vehicles in Europe. It's also used in Australia and New Zealand. Same basic vehicle applications we have as a combination between these two, and also it's used in Latin America and other areas also. So bottom line is this thing is used across the planet, and there's an awful lot of them that are out there, and a lot of them are being serviced right now. Clutch and band apply chart. Your clutch and band apply chart itself shows you that we've got 3 multiple disc clutches, 2 brakes, and of course 1 one-way clutch. Your 3 multiple disc clutches, as I told you, this is very similar to other 6-speed transmissions. You've got a 1, 2, 3, 4 clutch, a 4, 5, 6 clutch, and of course a 3, 5 reverse clutch. They call them out a C1, C2, C3. You also have a couple brakes. One of those is a band there we're looking at, B1. Just be aware we've had some problems with the B1 servo pin fracturing, causing obviously the servo to stick or give you like a slip type of condition or a no apply type of condition. So again, just something to take a look at when you get one of these things apart. Inspect the pin, make sure there's no evidence of any type of cracks in the servo pin itself. Comes to transmission pressure testing itself, there are some pressure test ports that are on this box. As you can see on the left-hand screen, you got C1 and C3 clutch. Right-hand screen, C2 and B2. Again, we're going to give you the specifics as far as pressure measurements are concerned right there on your screen. This is the one where we had the little hitch in the giddy up as far as the picture was concerned. And this is what the correction in your handout was about. We had some reversals of terminology as far as solenoid callouts because the valve body was oriented opposite of another picture. So the picture as you see it right now in your handout, as well as on the screen, the area that's shown in red, that indicates the correct terminology for those particular solenoids. As you can see, we got 2 regular on-off solenoids, shift solenoid A, shift solenoid B. And we got several pulse width modulation solenoids, again, to control the shift as well as to control the aggressiveness of the shift. Very similar to other 6-speed transmissions per se. We're listing you the resistance values for the on-offs and, of course, the PWM solenoids. So if you want to use your own meter on them, you can do that. Now, look at the middle of the valve body. You'll see what looks like little check balls in the middle of the valve body. There's 1, 2, 3, 4, 5, 6 of them that I count right here. Those are not check balls. Those are actually the pins that hold the solenoids in position. So those pins you will not normally see. There's actually a cover that goes over top of those pins to hold those pins in position. That cover has got to come off before you can actually remove the solenoids. So you pull the cover off, flip the thing upside down, and physically pull the pin out, and then you can then remove the solenoid itself. So again, that cover physically controls that pin to keep it from falling out, and that cover has got to come off before you can actually pull a solenoid out of the bore. The other thing I want to bring your attention to is the casting number on the bottom of the valve body. As you can see, this one is a 9172. So look at the bottom of the picture, right above where the manual valve is at, next to the TCC solenoid, you'll see that casting number, 9172. The 2 most common casting numbers you're going to see with this transmission right now is a 9172 and a 9174. They use different valve body gaskets. So just be aware that you're going to get multiple gaskets in your overhaul set. You have to make certain you line the gaskets up. If you fail to do that, what's going to end up happening is you're going to end up with a loss of line pressure because your line pressure will be bleeding out the end of the manual valve. So in order to keep that from happening, you got to make sure that you use the right gasket. So we can obviously do some interchange on this transmission, but the gaskets are one area that you cannot. Valve wear is huge with this transmission, absolutely huge. I cannot overemphasize how important it is to make certain that you check the valves for wear. I don't care how you check them for wear, whether that means that you're going to use a vacuum tester on them, whether that means you're going to manually check the size of the bore and the size of the valve, or you want to air check the valve. Whatever you would want to do is fine with me, but at least make sure you check them. These Eisen or Asian Warner type transmission valve bodies are very soft aluminum, and they tend to wear. We've seen wear under 20,000 miles on these transmissions. So bottom line is make sure you take the time and physically check them. Looks like we've got a question in it. It says, if the vehicle comes in with a bad solenoid, does the valve body have to be removed to replace it? I would certainly be obviously pulling the valve body. I don't know that you have to pull the valve body. I don't know if you can wiggle it enough to get the pin to come out, but the bottom line is I would probably be removing it simply so I could clean the bore and so forth. So again, some people do that, some people don't do that, but in this particular instance, it should be just like a bolt-on type solenoid. You should be able to replace it without doing too much hard work there, I guess is my point. So either way, you could do it. One of the other little tidbits, if you notice on the screen, we're pulling up a check ball that's on the inside of the valve body. We've had several instances where guys have left that check ball out. They forget about it. They pull the valves out to clean everything because of obviously valve body wear. Because again, this is a major, massive issue with this transmission. I've not seen any of these apart that have not had at least one valve, usually multiple valves that are worn out. So again, you're going to be your supplier's best friend when it comes to working on one of these. You're going to either have to repair the valve body, okay, or you're going to end up having to replace the valve body. That's the most likely scenario you're going to get yourself into. So solenoids have not been the problem with this transmission. It's been the valves per se. We've had a few solenoid failures, but nothing like the extent that we've seen with the valves. So again, back to our check ball. Again, guys have pulled these things apart, cleaned everybody, got everybody fixed, put everything back together, left that check ball out. If you do, you'll have a no reverse condition. So simply take a little bit extra time, make sure you get the check ball back in the bore. These are the typical valves that you run across issues with. Ford calls them modulator valves. You guys would call them regulator valves. Same thing. The solenoid controls the position of the valve itself, which in turn controls the pressure that goes to feed whether clutch or components that you're going to have. So bottom line is you need to check the valves in the valve body. The other thing you need to look at real hard, because we've had an awful lot of wear with this area also, you see the accumulators there. Those accumulators wear the bores out. So make sure you check the accumulators to make certain that the bores and the accumulators themselves are not physically worn out. Again, a huge problem we ran into with these transmissions as they start to get some miles on them. On the valve body breakdown picture, we got this from Maura at Sonics, so I thank her again. The regulated spring tension itself that you've got on the valves themselves, they're all color-coded, so these are basically little check valves. We're going to give you the spring dimensions, as you can see, as well as the color codes. Now, I might draw attention to that one at the lower right-hand corner of the picture. It's called lube number 2 with the red spring. No longer there on the updated valve body. So your spacer plate's got that all blocked off, and that's not used anymore. So the 9174 valve body is different than the 9172 valve body, as you're going to see as we get into this a little bit further. So now let's take a look at the gaskets and the differences between these two different casting numbers. The most common casting numbers you're going to run across are going to be these two casting numbers right here, 9172, 9174. Pull that little metal cover off that holds those pins for the solenoids in. and you're going to see those casting numbers cast right into the valve body. When you get your kit, you're going to find a couple different gaskets. Well, when you flip the valve body over, if you had both these valve bodies side by side, this is what you would see. You would see the 9172 on your left-hand side, the 9174 on your right-hand side. As you can see, there's a significant difference in the channeling of those two ports. If you're to intermix the gasket, you can end up with a low line pressure condition because that's the manual valve is where that basic gasket passage goes. And you'll end up dumping your oil pressure right out of the manual valve itself. So you want to make sure that your gasket matches up to what you in turn had pulled out of that vehicle. So just be certain that you look at both gaskets, compare both gaskets to what you've got. Back the same gasket. Now, the other difference in these valve bodies, you can see there's a slot up on the top. That slot is your B1 servo release circuit. These valve bodies will interchange as long as you interchange the spacer plate and gasket. So bottom line is you may have that blocked off, or it may be open where that servo feed is actually at. Again, don't be alarmed by it. It's just a difference in the two different castings that you see right there. So you will be able to interchange these, but you have to make sure the gasket and the plate interchanges with it. This is a look at the gasket on the plate. The 9172 is on the left-hand side. The 9174 is on the right-hand side. Again, as you can see, there's a significant difference in the layout of that gasket in those areas. So again, make sure that you do a comparison so that you don't get yourself in trouble. There's actually 5 different spacer plates for this AF21. Spacer plates lettered A1 through A5. The A5 plate, what's different about it is that C3 clutch. That's your 3-5 reverse clutch. Ford was having some issues, they said, with aggressive reverse. Most instances, the aggressive reverse could be adapted out. In other words, you cleared and relearned the adapts, you worked it a little bit, and pretty soon everybody was a happy camper. Some applications, though, they still had a little bit of a problem with it. So bottom line is that if you in turn had the C3 plate update, or I should say the A5 plate update, the A5 plate itself was designed so that it had a smaller feed hole for that 3-5 reverse clutch, which basically then limited your oil volume going to the clutch and smoothed the apply. Looks like we got a question popping up. Whose part numbers are they? Well, the A1 through A5, I don't know that this is a part number. This was a stamping number that they actually had. So I don't actually have, guys, the part numbers for these plates, just so you know. You're probably going to have to contact your supplier to get, obviously, the part numbers for the plates. Just be aware there are 5 separate plates that are out there. Lower right-hand corner, gasket numbers. Again, don't have gasket numbers, guys. I try to stay away from part numbers. You guys have been to seminars with me for years, though. I hate part numbers with a passion. And the reason I do is because manufacturers change them like you change socks. So I try to stay as far away from part numbers as I possibly can, because sure as heck, somebody will call me on the telephone and cuss me out because I give them a part number and it's not a good part number anymore. So you need to go to your supplier, just be aware that there are different gaskets and there are different, obviously, spacer plates that are out there. Go to your supplier. He should be able to give you a list of what it is you've got. B36 396 is from who? I'm not sure. I'm going to have to look at what we got there. So you'll have to clarify that question there, Rick. So I'm not exactly sure what you're asking. So anyway, bottom line, guys, is just make sure that you got the right gasket, the right spacer plate in your application, and you should be a happy camper. All right. Typically, when we tell people to pull solenoids out, one of the things we do at ATRA, and we've been pretty consistent with this because we want a consistent process across the board. We tell everybody to make sure they mark their solenoids and mark the bore that the solenoid came out of so they can get the same solenoid back in the same bore. Some transmissions flow test these transmissions or these solenoids. So you'd want to make certain that that solenoid is back in the same bore. This transmission is not quite like that. But we want a consistent process, so we're going to follow the same rules that we follow with all transmissions. Put the solenoid back in the same bore that it came out of. If for some reason you had obviously a bad day or whatever and you forgot to do that and you pulled the solenoids out and you had them on your bench and you're not sure what went where, the guys at Valve Body Express came up with a picture for you which identifies which solenoid goes where. So if you look at the picture, it will show you the ID cutouts that you've got so that you know how that solenoid is, which solenoid is actually going to go in which spot. So that basically is there for reference information in case you in turn do pull the solenoids out of the bore without knowing which bore they actually came out of. All right, this is kind of where the rubber meets the road right here. We're looking at each of the individual solenoids that you can see there. We've got shift solenoid C, which controls the C1 clutch, shift solenoid D, the C2, shift solenoid E, the C3, and a shift solenoid F, which is the B1. And of course, you got your pressure control solenoid, your TCC solenoid, and so forth. And of course, your two shift solenoids, your on-off solenoids to make the car move forward and backward. Next to those regular shift solenoids, those PWM solenoids, you see something called out as adjusters. There's a C3 adjuster on the left-hand side, a B1 adjuster on the left-hand side, then a C1 and a C2 adjuster on the right-hand side. Those adjusters are pretty critical. And one of the things we've always told you with those adjusters is to make sure you measure the depth of the adjuster itself prior to removing it. Most guys will actually pull those adjusters out of the bore to clean the valve body. So there's a cleaning process. They pull the adjuster out, which basically then means that they've got to back the adjuster off one way or the other to get the adjuster out of the hole. So if you're going to do that, this is what we want you to do. These adjusters are set to a baseline value at the factory. If you've got a reman valve body, they were set to a baseline value by whoever the reman company was. It's important that you maintain that baseline number. So my point is you use a dial indicator, I shouldn't say dial indicator, a dial caliper, and on the plunger portion of the dial caliper, you can measure from a machine surface on that valve body where that adjuster is actually setting at. So let's say the tip of that adjuster is sticking out 1/4 inch. On a piece of paper, we'd write down C3 adjuster, 0.250 inches. And so now, no matter what we did with the adjuster, when we put it back in the hole, we would adjust that adjuster to that 0.250 inches. So that puts us at the baseline. If you don't do this, then what can end up happening to you is you can end up with this baseline adjustment way off in the weeds, and you'll spend a tremendous amount of time trying to get those adjusters adjusted correctly. So everything we're going to do from this point on is based on making sure that you've done this baseline adjustment correct to begin with. So I can't overemphasize how important that actually is. Now, the adjusters you don't mess with once you get the baseline adjustment done until you've already relearned the transmission and found out that you still had an objectionable shift. So if the shift, after you do a relearn on this thing, you cleared the adapts and relearned it, and you drove it for at least 30 minutes, preferably up to 60 minutes, and it still has an objectionable shift, then we're going to mess with the adjusters. If the shift was good, we would leave the adjusters at whatever a baseline number was that we determined from before. So that's the gist of everything that we're going to do from this point on. So just to reiterate how this process is going to work, you disassemble the valve body, you pull everything apart, you measure those adjusters prior to disassembly. When you go back together, you put the adjusters back in and you reset those adjusters to whatever that baseline value that they were set at prior to you disassembling the transmission. You put the transmission together, you put it in the car, you clear the adapts, you relearn the adapts. You take it for about a 30 to 60 minute test drive. 90% of your shift problems will be non-existent at this point, because effectively you have done everything you should do with this transmission to eliminate a problem shift. whether that means a flare, a bump, a tie-up, a hard shift. Most of those things will be gone if you follow these guidelines. Now, if for some reason you have an objectionable shift after you've done exactly what we've talked about, which was, again, set the baseline adjustment, put the transmission together, make sure all your clearances and specs were followed, clear the adapts, relearn the adapts, test drive it for about a half an hour to an hour long test drive. Once you've done that, if again the shift is now objectionable, you're going to have to go further. At that point, you're going to go through and you're going to be adjusting those adjusters. So hopefully that makes sense to everybody. You can adjust the adjusters till you're blue in the face, guys, if this valve body is worn out. So again, I cannot overemphasize how important it is that you check the valves and you check the accumulators for wear. Both accumulator and valve wear are so common that it's not even funny in this transmission. So now we're up to the point of adjusting the clutch pressure. We got an objectionable shift. We did everything we're supposed to do. We followed all the rules. So I'm going to go through the rules one more time for everybody. When we pulled it apart, we pulled the valve body apart, we checked all the valves for wear. We fixed whatever valve issues, accumulator issues we had. We fixed whatever was wrong with the transmission itself. We got all our specs put together, and so everything was put together according to the proper clutch clearances, in plays, and so forth. Seal rings all are replaced. Everybody's a happy camper. Now, at this point, we got the transmission ready to go back together. The valve body, of course, we said was repaired. We established our baseline adjustment for those adjusters. We put it back together. We started the car up. We drove it a little bit. We cleared the adapts. We relearned the adapts. We took it for an extended length test drive, varying the throttle opening and so forth. Now we have an objectionable shift. No matter what that shift is, it's considered objectionable. So the bottom line is it might be a hard shift, might be a slipping shift, might be a tie-up, might be a bump. We've got something that's objectionable. At this point, we're going to want to adjust these clutch adjusters. Now, when you adjust those adjusters, effectively what you're doing is you're varying the spring tension on the end of the solenoid valve. So the valve that solenoid is controlling, you're simply varying the tension on the end of that valve. So as we turn it one way or we turn it the other way, it's going to change the pressure. So this was Valve Body Express's process that we're going to follow here, which they've had very good luck with, and I appreciate them sharing it with us for actually doing the adjustments. So we're saying we had something that varied a little bit in this transmission. In other words, we got a little leak we weren't accounting for, we didn't catch one of the valves being worn, something like that, and we got obviously an objectionable shift. Delay going into reverse, a flare, a hard shift, something like that that we could not fix by simply relearning the adapts. At this point, we're going to go to the adjusters. Now, if this is a Volkswagen, those adjusters would be called out as Ks for the K3 clutch. Since this is not a Volkswagen, it's a C for a clutch. So a C3 adjuster, if we have a reverse problem, we're going to turn that thing counterclockwise 3/4 of a turn. Now, we'll go clear to the bottom of the page. If we had the opposite type of effect where we got a firm 1-2 shift, we're going to turn the B1 adjuster clockwise 3/4 to 1 turn. So again, not a lot of movement makes quite a bit of difference as far as how this transmission works. So that's the reason we don't want you messing with these things to begin with. As your baseline is done and done correctly, you should probably not have to go through and do this after you've done the adapts. About 10% of the time, you're going to have to go through and do this. So if you do have to, this is the basics of how you deal with it. So we're showing you which adjuster you screw back and forth and which direction you actually turn it and how far you actually turn it. So now if you look at the adjusters themselves, what we're primarily doing is we're varying the spring tension. So let's take a look at the C1 solenoid and the C1 adjuster. If you notice, the C1 adjuster is right across from the C1 solenoid. So what we're doing is, again, as you adjust that adjuster, you're simply varying the spring tension on the end of the valve that the solenoid is actually controlling. That's the reason it's having an impact on whatever that particular solenoid controls. So again, do not mess with the adjusters unless you followed all the other guidelines we've given you. At that point, you pull up the chart that we've given you in your handout, and you adjust whatever the corresponding adjuster it is that you need to make adjustment with to take care of your particular shift complaint. Now, we talked about doing shift adapts. There's actually a couple different types of learn procedures Ford has for these vehicles. This top one here is a pretty self-explanatory one. This is basically nothing more than resetting your Prindle switch. So what we're saying here is that you're going to take your scan tool and your Prindle switch values have got to match the actual gear positions you put the transmission in. So we're going to adjust the TCM back and forth in order to get that obviously correct. The bottom section of this page is actually the relearn of the adapts themselves. So it's as simple as following step by step to do the relearn. So you're going to have a scan tool, you're going to have to reapply the brake, put it in and out of gear, you're going to have to drive the vehicle, vary your throttle opening, a whole bunch of different steps just like you do with other vehicles to do the relearn. Once you're done with the relearn, you operate the vehicle for a minimum of 30 minutes, then evaluate your shift. Again, if your shift is not objectionable at that point, you're ready to send this to the customer. If it is objectionable, then you're going to have to physically adjust those adjusters. Well, hopefully everybody followed along with this whole thing and understood what we're doing here with everything. I think we've pretty well come to the end of our presentation for today. Looks like our time is about up. I don't see any other questions popping up. Again, thanks again to CL Aftermarket Products for sponsoring our webinar. And again, if you got a question, pop her up on the screen. I'll try to answer your question for you. With that said, it doesn't look like we have any other questions popping up, so there should be an automated survey that pops up after the end of our presentation. We'd appreciate you filling that out, and we'll hopefully see you guys in 2 weeks for the 722.9. Everybody have a great week, and we'll talk to you later.